Okay, welcome to Module 8. This is our second last lecture of the course, and we're going to be looking at geocoding, which is something that we use an awful lot in our real world situations and daily situations, but learning how it's actually created and dealt with is really important. So that's what we're going to talk about. It's a relatively short lecture, but we'll, we'll get through the basics of it anyways. So really the whole purpose of this lecture is to talk about the geocoding process and what's available to do it and what's needed to do it. The actual creating of the data comes in the assignment that you have, but this is just to introduce what you need to do. So let's start with the question of what is geocoding. Geocoding is converting addresses to point locations. That means if you actually think about it, when I give you an address, I'm actually giving you an attribute of a location. I'm not giving you an actual spatial coordinate. So a street name, the number of the house, even if I gave you a legal description of the house, all of that is actually just an attribute. So what we need to do in GIS is to convert that address to an actual point that has a coordinate. So what's neat about this is that it is because it's like an attribute, it's very similar to joining a standalone table and with another attribute table. So we want to take those two, put them together. That's pretty much exactly what we're doing, except a little slightly more complicated way, and that it has a couple exceptions. So one of the exceptions is that it can use multiple fields to match records. So if you think back to doing an attribute join of a standalone table to an attribute table, you can only use one field. This time around, though, we can use multiple fields to see how they actually match up. We can also match records that are similar but not exactly the same, which is also really helpful because if I'm trying to find a location, I don't really need to know the exact pinpoint position of a house. And really, what am I trying to identify at that house? Am I trying to identify the front door? Am I trying to identify the center of the house? Am I trying to identify the corner of the property? Right? So it doesn't need to be exactly the same. It just needs to be somewhat close. And with that, we need a spatial data set that goes with these attributes. And that spatial data set is known as the reference layer. So here is a table. You can see that we've got, for example, golf courses and the different number of holes that are there, whether it's public or private. We have a street address and a city. What we're really trying to do is say, where are these? So we have the street address, but we have to put everything into coordinates. So that is what geocoding does. So there is a term called fuzzy matching, which is where things don't have to be exactly the same. And it can be performed using different attributes such as city, state, country, postal codes, township or range, street addresses, and those street addresses can be matched using one range or two range, and I'll get to that later. So we don't necessarily need to have just a street address. We can have other methods and other attributes that will allow us to geocode. So that leads to some of the requirements that we need. So the very first thing that we need is a reference layer. Like I mentioned, we need something that has some spatial information that we can convert our address attribute to that spatial information. We also need an attribute table with those addresses, so that's number two thing that we need. And then we need to create an address locator. Sometimes there's built-in address locators, other ones we create. And then you actually perform the geocoding itself. So to go in a little bit more detail about the reference layer is a point, line, or polygon with attributes that the matching will happen. So for example, here I have write from address and write to address. So it gives me the range of information on Riverdale Ave, for example. So I know that the numbers are going to be 1200 to 1398. So this gives me a range of values. And then it gives me the name of the street, the street type, the city, the quadrant, etc. So all this information is required to be able to match in this case. Then the second geocoding requirement that we have is the attribute table with the addresses. So the street address attributes is kind of the important thing. And this is really applicable to 1 or 2 range geocoding. So we can look at prefixes. So for example, if some cities have the prefix at the front, then we have prefix types. So for example, like a highway, we have the number, we have the street name, we have the street type, so drive, avenue, whatever it works out to be, street. The suffix directions, so in Calgary, for example, we have everything in octants. So we'll say northeast quadrant, or quadrants is really what it works out to, but we have a northeast quadrant. And then there's city, state, and zip codes, which are also optional. So with this table, the addresses are parsed or broken down to its pieces. So as I was pointing out, that the single address, we can break it up into different sections. And I'm sure you've come across a form somewhere that you've had to do that. It's like, okay, what's the number of my house? What's the street name? What's the type of street? What's the direction or the octant or quadrant that it's in? Maybe you might have a prefix. Excuse me. So any of those, you got to break it all up. So we're taking one big long string and breaking it up into its pieces. And then this breaks it down to, there's 2 different kinds of geocoding with this, with street addresses. There's 1 range and 2 range. So for this example, the 1 range, if we're going to use a 1 range geocoding, it only requires 1 range for each road segment. And so we have just, we might have starting at 10 and it goes to 100. And so we know all the way along that section, no matter what value it is going to fall on that line. To be able to do that is way less extensive and way cheaper than trying to figure out what side of the road it's on. When we don't need to know what side of the road it's on, it works really, really well. You need to have line or polyline geometry in order to run it, just because you need it along that line. And then the fields must also contain the from address and to address. So that's the starting point of the number to the end point of the number, and then also the street name. There should also be other information such as the prefixes and street type and such, but that's really the most important thing, is having that range of addresses and the street name that goes with it to be able to figure out that 1 range geocoding. If we have dual range, this means that we have both sides of the street. So 1 range means you just have 10 to 100, and that's all you need to know, and it's somewhere along that line in some consecutive order. With dual ranging, we're on one side of the street, we're going to have odd numbers, and the other side of the street, we're going to have even numbers. So what that does is allow us to determine not only where is it along the line, but also which side of the street it is. So with this one, it's a lot more expensive and a lot more extensive. So we need really define what's going on with that data. And then the side of the street is essential. So we need to know what is it, on the left or right, north or south. That's really important. We also need line or polyline geometry as well, because it's going to run along that line. And you need the same information. So the from address, the to address, and the street name, and should have those prefixes or street type, etc., to be able to match properly. Now in Europe, they don't have the same repetitive names as what we do in North America. And I'm not sure about other parts of the world, but I know that they have very unique names for each of their roads, where here you might have something that has the same name, but it changes ever so slightly depending on what part of the community you're in. So you have to be really with that attribute table, the geocoded addresses, they end up being placed as points, and it's an approximate location along the line segment. So you can imagine along this line, for example, it goes from 300 to 399. About halfway through is about 350. About a quarter of the way through is 325, and that's how it's going to locate it. It also puts an offset, so that shows you that either side here, we're using a dual range geolocator. Then the next thing we need to do is create an address locator. So this is the way that we take the address, which is an attribute, to an actual address on the map, which gives it a spatial piece of information. And it's known as an address locator, and it just needs to be applied to the reference layer. So you can see here as an example, we have our reference data, we have the role that it's supposed to play, and then we have a field map of where those points are, and that becomes our locator. Then we perform the geocoding. So geocoding, we press go. It matches the field values in the address tables to the field values in the reference file, and it uses that address locator to be able to do that and pull everything together. And then you got your result. So that's geocoding. That's the big lecture about the entire module for today. The process of it, so just kind of in summary of talking about that, it converts addresses to point locations. So we take attribute information that it has to do with an address that we would say verbally to each other and creates a spatial point in space. So many businesses rely on it now. In fact, like you probably rely on it to use your Google Maps when you're navigating, or even any kind of GPS unit that you're using when you're trying to navigate with it. It's like very, very common, and it's like super, super heavily used now. So you need to know how to do it. And just remember that it does require a reference layer that has points, lines, or polygon features with attributes that will be matched. For the most part, line information is the best, and it's the easiest one to use, but it can be done with the other ones. So there's no readings. There is a geocoding tutorial on the ArcGIS Pro website, so please check that out. And then you get to complete assignment 5, and that is everything.